This problem is an example of what to do when you're given something to factor like this 9x squared minus 4, and it's not in that standard form that we're used to. So standard form looks like this, just to remind you, ax squared plus bx plus c, where a, b, and c are all numbers in your expression. So if we go back to our example problem, you can see that we have 9x squared, that's the a position, and we have a number in here for c. So what we're going to do is just add the missing piece, which is this bx. You can see that that part is not in our expression at all. So we're going to add it, but we're going to add it with a 0 in front, so that it doesn't actually change anything, because it's just 0 times 0 times x, which is just 0, so we're not really adding anything. We're not changing anything, but we're putting it in a format that makes it easier for us to factor. So 9x squared plus 0x minus 4. Now it looks like what we're used to, and we can factor it using that x box method. So we're going to go ahead and do our x, we're going to do our box, and we're going to start factoring. So remember, you're going to take this 9x squared, plug it into one corner, and then the 4, the negative 4, goes in the opposite corner. And then we're going to do our diagonal. So 9x squared times negative 4 is negative 36x squared. And we take that negative 36x squared and we plug it into the top of our diamond problem. Okay, so this piece right here, this is how we're going to split up this 0, or how we're going to create 0x. But that doesn't mean that it's automatically zeros, okay? It just means that when you add these two boxes together, they add up to 0, or they cancel each other out. So what we're looking for is two numbers that when I multiply them, they multiply to negative 36, but when I add them, they add up to 0 x's, okay? So 36 is the number we're trying to factor. Now let's think about this. Negative 36. So one of these numbers has to be positive, one of my numbers has to be negative, but when I add them together, they're going to add up to 0. That means they have to be the same number. So two numbers that I can multiply and get 36, that's going to be a 6 and a 6. Now, since I want my 36 to be negative, right, that negative 4 caused the diagonals to be negative, then one of my 6's is going to be a negative 6. Now, when I add those two together, I get a 0, which is what I'm looking for up here. That's that thing that I added to my expression. So I have a negative 6x and I have a positive 6x, and we're going to plug those into our area model. So negative 6x and positive 6x, and then we're going to double check our diagonals. So 6 times negative 6, negative 36x squared. Our diagonals match, so I know I have the right set of numbers. And now I can pull out my little factors outside for each box. So this row right here, the 9x squared and the negative 6x, have x in common for sure, and I can also pull a 3 out of both of these evenly. So I'm going to put a 3x right here, and then I'm going to work my way around the box. So 3x times a number is going to give me 9x squared, so that's going to be another 3x. 3x times a number is going to give me a negative 6x, so that's going to give me a negative 2. And then 3x times a number is going to give me 6x, that's going to give me a positive 2. So my factors, my final factors, are my sides. So I have one side, which is 3x plus 2, and I have my other side, which is 3x minus 2. Okay, so notice how these two look very similar. One's positive and one's negative. There's a special situation up here which we will go over in a later section, and it shows you a shortcut so that you don't have to do all of this method. But today I just want you to realize that if you're missing a term from your standard form, all you got to do is add it. So if my expression is missing the c piece, then I just add 0. If it's missing the x squared piece, then I just add 0x squared. All right, that's it. Let me know if you have questions.